Good afternoon, ladies and gentlemen. I'm Samuel Estala Arias, and I will present an abstract of my work entitled Distribution of Cross-Sections in the Hilbert Modular Orbifold. I realized this work as a PhD student at the Universidad Nacional Autónoma de México. I will divide the presentation into four steps, beginning with an abstract, then a settings, main results, and the classical case of the modular orbifold. We will begin with an algebraic number field together with his Hilbert modular orbifold, and the probability measures uniformly supported on the cos cross sections of the Hilbert modular orbifold at high Q. We generalize a method of Sagier and show that MQ distributes uniformly with respect to the normalized hyperbolic measure M on the Hilbert modular orbifold as Q tends to 0, and relate the rate by which MQ approaches M to the Riemann hypothesis for the Dedekind zeta function of the number field key. So the setting is an algebraic number field key of degree n with R1 real places and R2 complex places and ring of integers O. With this we have a Riemannian manifold or symmetric space formed by the product of R1 hyperbolic planes and R2 hyperbolic spaces, and we have that the Hilbert modular group acts properly and discontinuously on this symmetric space by a formula related to the Mobius transformations. If the field key has class number H, then the Hilbert modular orbifold has H cost, and each cost can be parameterized by the standard cost ad infinity. Therefore, we have a manifold with a finite number of ends or costs and some singular points. From the geometry of the Hilbert modular orbifold, it follows that for each cost and each real number bigger than 0, we have a generalized closed autosphere, which are essentially a manifold which is transversal to the cost. So it has a codimension 1, and in this manifold, in these submanifolds of codimension 1, we can define probability measures which are related to the Riemannian metric inherits from the ambient space. So we normalize each measure to be a probability measure, and we have the following result. The main result of this work tells us that the measures MQ are uniformly distributed with respect to the normalized hyperbolic measures, and this tells us that when the volume of the manifolds increases, they start to cover the Hilbert modular orbifold uniformly, and we get a picture like the following one. So here we have a picture where the volume of the submanifold is getting large and it starts to cover the whole Hilbert modular orbifold uniformly. The final result is a result proved by Sagier, which relate the Riemann hypothesis to this distribution theorem. We found that the measures which are transversal to the costs gets uniformly distributed with respect to the hyperbolic measure in a certain speed, if and only if the Riemann hypothesis for the Dedekind zeta function of the field key is true. Finally, we have here a picture of the classical modular orbifold, and we begin with a picture of the Dedekind tessellation of the hyperbolic plane, and the quotient space is the classical modular orbifold. We have a closed Otto cycle and another one which is larger, and it started to get enrolled in the classical modular orbifold. Finally, when the volume is getting large, it starts to cover the whole classical modular orbifold. This is related to the Riemann hypothesis and with the prime numbers that I have pictured here with Maya numbers. We highly recommend a video for a simulation in the case of the hyperbolic plane, and the direction is right here. Finally, we want to thank Professor Alberto Verhovsky-Solá for suggesting the research of Salguero distribution theorem in the case of the Hilbert modular orbifold, and for all his great explanation in this remarkable subject. I'm Samuel Estala Arias. Thank you very much, and see you later.